Okay, so if you're a software engineer right now, you've probably felt it. That little prickle of anxiety.
Ugh.
Hearing all the talk, sometimes it feels like shouting, that AI is coming for your job.
It's everywhere.
The hype around AI coding, it paints this picture where, I don't know, in a year, half of us won't even be here anymore. It's
Yeah.
it's pretty unsettling.
It really is.
But what if that whole story is missing something huge? What if the reality is actually, well, a lot more nuanced, maybe even exciting?
You've absolutely hit on something crucial there. I mean, the hype machine is definitely running at full speed,
Right.
but so many of those really bold predictions, they just seem disconnected from, the day-to-day reality of big, complex production systems.
Mm-hmm.
It honestly feels like a lot of the people making those grand claims, well, they haven't actually touched a messy real-world code base in a very, very long time.
Okay, right. Let's unpack that because
Yep.
you hear a number like AI can generate 30% of the code, and that sounds, well, incredibly disruptive.
It does sound like a huge leap.
But does writing, say, 30% of the lines of code really mean 30% less human effort needed? Is that the whole picture?
Probably not, no.
So our mission today is really to cut through that noise. Let's try and understand what AI really does in coding and, give you some practical ways to think about it, navigate this whole thing.
Good goal.
We're going to dive deep into why maybe software engineers won't be replaced, what AI is actually good at right now, and how you might effectively use it in like real-world production
The
systems.
stuff that actually has to work.
Exactly. So if AI can crank out a bunch of code, why doesn't that just directly replace people? What does it mean for engineers on those huge projects, the ones lasting years with thousands of people involved?
Well, think about those really, really large code bases, like, say, at a company like Meta. You might have an engineer literally working on one specific button, maybe in the ads platform, for like 6 months.
Wow, okay.
In that kind of environment, there's just not a lot of wiggle room for completely free-form AI code generation. The context is already so heavily defined.
Right.
Every decision about that code, the architecture around it, the infrastructure it runs on, that's all been decided maybe years ago. The path is incredibly narrow.
But AI is writing code. We see it. People are using Copilot, other tools.
Oh, absolutely. It is writing code, no question. And here's the thing. It's the same kind of code we've been writing for, what, 50 years?
Yeah.
Same programming languages, same
Yeah.
basic structures, nothing fundamentally different there.
Yeah.
But that code, whether a human wrote it or an AI wrote it, still has to run in production.
Yeah.
And anyone who's run a large production system knows
Oh, yeah.
even the most carefully written code can fail. And it often does in weird ways.
Yeah.
Complex systems, they have emergent behaviors, stuff you just don't see looking at one line of code.
The unpredictable interactions.
Exactly. So the critical question is, when that AI-generated code breaks, maybe at 3 a.m., who's going to fix it?
Yeah.
Who has the deep understanding to examine it, figure out the nuances, and get things stable again?
This feels familiar, doesn't it? It's not like this is the first big tech shift that's made people nervous about their jobs.
Not at all. It's almost cyclical. Think back like 15 years ago, the whole DevOps transformation, or the big move to cloud.
Right. Sysadmins were supposed to disappear.
Everyone predicted the end of the sysadmin. But what actually happened, all the sysadmins I knew, the ones racking servers, booting kernels, they all got pay raises.
Yeah.
And now they work on much more valuable, higher-level problems. It's a shift, yeah, a profound one, but not elimination. It's like the old analogy, tractors didn't get rid of farm.
They got rid of farm hands and horses.
Exactly. The industry changes, the tools change, but the core need, in that case, farming remains. And I think it's similar here.
That's a great parallel. Okay, let's talk about this term vibe coding. I've heard it pop up. What exactly is that, and why, as you suggested, does it maybe not cut it for serious production software?
Yeah, vibe coding. It's basically this idea of letting the AI write pretty much all the code, do the thinking behind it, and the human engineer, well, they don't really examine it deeply.
Just sort of eyeball it.
Kind of. Like, does it feel right? Does it seem like it does what I asked? And then you move on.
Right.
But that is just a world apart from production-grade software.
Right.
When I say production, I mean systems that need like 4 nines of uptime, 99.99% available. Systems serving thousands, maybe millions of users, handling tons of data. The software that actually runs the internet.
You can't run the internet on vibes.
Exactly. The real world is just too messy, too full of edge cases, and weird failure modes for that.
It seems so obvious, though, if you can generate the code, that's the job done, right? So where does that thinking go wrong? Why isn't generating code the whole job?
Because code is not the job.
Hmm.
I mean, think about an architect. Do they just draw blueprints?
Well, no, they design the building, consider materials, regulations.
Exactly. The blueprints are just an artifact of that process. They aren't the whole profession. It's the same for software developers. Yes, we output code, but before that, we make thousands of decisions.
Like,
What is this software even supposed to do? What kind of system is it? What libraries or packages should I bring in? Which ones should I avoid? We need to stop confusing the act of typing code with the actual engineering work. You know, Jeff Atwood, co-founder of Stack Overflow, he famously said, the best code is no code at all.
I've heard that, because every line is a liability.
Precisely. Every line of code you write or that an AI writes for you comes with a burden.
Yeah.
You have to maintain it, debug it, understand it eventually. So every line an AI generates, you, the human, are still on the hook for it.
So it's almost this weird counterintuitive thing where the more code the AI generates automatically, the potentially bigger your maintenance headache becomes down the line.
It absolutely can be, yeah. If you're not careful, if AI isn't making those fundamental design decisions, what is the real core work of software engineering then?
Well, what is it?
LLMs, they don't make decisions in the human sense. They generate text. They're incredibly good at pattern matching based on the vast amounts of text they've seen. But at a certain scale, or when you hit a unique problem, there's no existing pattern for your specific software. Every production system, if you've worked on one, it becomes kind of a snowflake, right?
Yeah, it has its quirks.
It has its own weird history, its own idiosyncrasies that only the team really understands.
Right.
Pattern matching breaks down there. So when that system falls over at 2 in the morning, vibes won't help.
Someone needs to know why.
Someone has to diagnose it. For me,
Yeah.
the real job, what I've done for 20 years, is basically changing software safely.
Changing software safely, okay.
How do I add this feature or change this existing behavior without breaking everything else? How do I do it safely so the whole thing doesn't crash? And we do that through, our own knowledge, version control testing, type systems, careful deployment strategies.
All the established practices.
Right. AI can help. It can give you context about a code base, maybe suggest ways to do things, but it doesn't replace the fundamental need for human judgment or that ultimate responsibility for keeping things running.
What's really fascinating, and maybe a bit strange, is seeing how professional software engineers often seem to be the last people really jumping onto the AI bandwagon.
It is strange, isn't it?
Yeah, because usually with things like version control or cloud or microservices, developers were the first ones saying, yes, give me that. Why the hesitation this time, do you think?
It's a really interesting anomaly. I've been at DevTools for ages, and I've never seen this kind of reluctance from developers. Usually it is, hell yes, give me the new shiny thing.
Right.
I have my theories, but I don't think anyone fully understands why so many engineers are still like, I'm not touching AI. Can't really do what they say.
Maybe just the pace.
Well, and we do have to acknowledge how incredibly fast these tools have changed. A couple of years ago, mostly junk, frankly, pile of bricks.
Yeah.
Then maybe a year ago with models like GPT 3.5 and similar, you saw this massive leap in quality. And then literally just a few weeks ago, this idea of agents just exploded. Now every AI coding tool has them.
It's dizzying.
The pace is unbelievable.
So given that speed, let's get practical. How do we build software or set up our teams in a way that makes it easier for AI to help? What are the best practices that prepare our code bases for AI integration?
Okay, yeah, practical steps. There are definitely things that help bridge that gap. First, you really need documented standards and practices.
Makes sense.
Your code base is always changing, right? So document your decisions. Which library to use here? What architectural pattern we follow now? Let the AI know the direction you're heading. It can't guess your team's evolving standards.
Got it. What else?
Second, reproducible environments. Can anyone on the team easily spin up a working developer environment? Or is everyone's setup slightly different, bespoke?
The works on my machine problem.
Exactly. AI can't navigate a super custom, non-reproducible setup like a human might eventually figure out. Make it easy to get started. Third, easy testing.
Crucial.
Can you run tests locally? Are they fast? AI will generate code. That code needs checking quickly, just like any code.
Okay. Standards, environments, testing.
Fourth, clear boundaries. You can't just give an AI a super vague, high-level idea like, hey, extract this big module using the Strangler Fig pattern. That's like a multi-month refactoring project.
Way too abstract.
Way too abstract. You need to give it clear boundaries for what you're trying to build right now and maybe some hints on how. And finally, related to that, clearly defined tasks.
Treat it like a junior dev.
Pretty much. You wouldn't give a human junior engineer a vague task like, could you maybe make this button do something different?
Uh-huh.
But I still see people prompting AI like that.
Yeah.
Be specific. Define the task clearly.
So listening to all that documented standards, reproducible environments, easy testing, clear boundaries, defined tasks. Hang on.
What?
That just sounds like good software engineering practice, stuff we should be doing anyway.
Exactly. You absolutely hit the nail on the head. If your engineering setup already has these qualities, chances are your team's productivity is already pretty good. AI needs the same things human engineers need because at the end of the day, it's doing the same basic job. It's writing code. Think about it. No human engineer writes perfect code in one shot.
Right.
We all make mistakes, run the tests, fix things, lint the code.
That's right.
We iterate. But for some reason, there's been this weird expectation that AI should just spit out perfect, finished code on the first try. That was never realistic.
Good point.
So when you think about adopting AI, you have to make sure your systems are set up in a way that any engineer, human or AI, can actually be productive.
Okay, so if AI is going to be writing more code, maybe assisting with bigger chunks, so what does that mean for our skills? What becomes the most important skill for us human engineers to focus on or maybe rediscover?
Well, that's easy. Code review.
Code review.
By far. Code review is going to be, I think, the most critical skill. And honestly, it's probably a skill we've kind of forgotten or let slide as an industry.
How so?
Well, think about interviews. We focus so much on these like esoteric leak code problems. Maybe we should be asking, can you actually read someone else's code and give constructive feedback? Can you tell me why this is good or bad?
That makes a lot of sense, especially if an AI wrote it.
Exactly. As agents write more and more code, being able to effectively review, understand, and critique, that code becomes paramount. And frankly, our current tools for code review often, well, they kind of suck.
Yeah, diffs aren't always intuitive.
Getting just a list of changed files sorted alphabetically, that doesn't tell you the story of the change. It doesn't help you understand the flow. I think we're going to see a big explosion in better code review tooling and processes. That's the skill to brush up on.
Okay, final stretch. For those engineers listening who are still maybe a bit skeptical or just hesitant to dive in with AI tools, what are some final, really practical tips for working effectively with these LLMs?
Okay, 3 key things I've learned. First, remember, AI talks like a human, but it is a machine.
Don't get fooled by the chatty interface.
Exactly. I had this one time I was getting frustrated, and the AI actually apologized and said something like, oh, sorry, I just scanned that file, I didn't read it. What does scan even mean for software?
Right, it's just generating text.
It's generating text based on patterns it saw in emails, where humans say, I skimmed it. Don't anthropomorphize it too much. Don't forget, it's just generating text patterns.
Good reminder. Okay, number 2.
Second, sometimes code is just different, and that's okay. The AI might generate code that looks different from how you would have written it. But guess what? The person sitting next to you probably writes code a bit differently too.
True.
You have to accept that. Ask yourself, is this code actually better, or is it just different? This is why we have linters and style guides, right? To enforce consistency automatically and stop arguing about tabs versus spaces. Let go of some of that it has to be my way feeling.
Focus on function over personal style. Got it. And the third tip?
Third, write a rules file and define a create refine loop. Always start by giving the LLM context. Create a simple file, call it rules.md or whatever, listing your stack, your coding guidelines, key architectural choices. Give it that context first.
Okay, from the pump.
Exactly. Then follow this loop. Plan. Maybe even have the LLM help you write a markdown file outlining the plan for the feature. Then create. Let the agent generate the code based on that plan and your rules file. And finally, refine.
The human step.
Right. This is where you go in. Use code completions, make manual tweaks, maybe give more specific prompts to adjust things, then repeat the loop if needed. Plan to go. Create neckend. Refine.
Iterate again.
Iterate again. Doing it this way, you get much more comfortable prompting. And it's actually a really efficient way to work, especially if you let go of needing the code to be exactly how you'd write it and just focus on getting good functional code merged.
That makes a lot of sense. So the big picture here, the main takeaway, it seems really clear. The future isn't AI replacing engineers. It's about augmenting us.
Yeah, transforming the work.
making us potentially more powerful, focusing maybe on different skills. The jobs aren't just vanishing.
No, definitely not. It really is about shifting perspective, moving away from this code has to look exactly like my code and towards is this good functional code that solves the problem and leveraging AI to get there faster and maybe more consistently.
Which leaves us with a really interesting final thought for you, the listener, to chew on. If Jeff Atwood was right, and the best code really is no code, and AI is getting fantastic at generating lots of code, how might we need to rethink the whole software engineering process, maybe moving beyond just writing lines of code towards truly engineering solutions that are elegant, minimal, and have the smallest possible surface area for bugs? How do we leverage AI for that?